Hi, my name's Dave Clark and I am the How. In this Framework Afield programme, I'm hoping to take the listener on an acoustic journey within an acoustic journey. So let me explain that. Recently, I've been collecting all kinds of sounds that I've recorded in the field. And these range from chainsaws in the distance to Arctic terns crying over the sea in the Shetland Islands to wind turbines and all kinds of things. So sounds like a spring being stroked with a piece of metal, which has then been transformed through some treatments to sound like this. So that kind of creates a very, sort of hypnotic type of interstellar, spacey type of sound. To another sound, such as this, which is just the plucking of a rubber band to make this sound, which is the menacing pulse of Titan that you'll hear in the Rings of Saturn Part 1. So again, the idea there is to take an everyday object and transform its sound into something which I hope sort of represents Titan's looming presence in the background of the ice-bright Enceladus. And then one last one. This is some birds which will appear in the final piece, which is Io, Part 1. Now these birds were recorded in the Shetland Islands. There were many different types of birds there, so many different types of birds. The oyster catchers were ever present, and they sounded like this. And then with a little bit of treatment, I was able to transform that raw sound into this. And what I've done is I've put them together in four pieces under the heading Moons of our solar system. And this isn't the moon that we can see from our planet Earth. These are moons that orbit some of the other planets in our solar system. The moons of the solar system, and indeed the planets, up until recently, quite recently, were considered to be completely dead places. But we now know that's actually not the case. There's a huge amount of geological activity and climate on both the planets themselves and their moons. So I've focused on three pieces, Part 1, Part 2, and Part 3, of a moon called Enceladus, which orbits the gas giant Saturn. And I've also included the Part 1 of Io, which is a moon that orbits Jupiter. So what I'll do in between each track is talk a little bit about the moon itself and where the acoustic sound piece hopes to take the listener. So, on to the first part. Rings of Saturn with Enceladus and Titan, Part 1. While Titan appears in the background, its looming presence dominates this soundscape with a menacing pulse. And as we journey towards Enceladus, we hear the haunting interference of Saturn's rings. Enjoy the piece.
How far away are you?
So as we silently drift through space, we move to part 2, the geysers of Enceladus. So a closer look at Enceladus, some of the images that have come back from a probe called Cassini. It showed some mind-blowing images of water as it spews from the deep cracks in the ice crust of Enceladus. The water's coming up from what's thought to be a deep freshwater ocean. It's a geology that's probably derived from the immense gravitational stretching effect of Saturn. And it was an image that changed the way that we see our solar system. The camera on Cassini was turned away from the glory of Saturn for a moment to see what was going on with some kind of weird magnetic readings, I think, that they'd got from the probe. And as they turned the camera, the sun shone from behind and illuminated these freshwater geysers as they spewed miles, thousands of miles into space. Again, the soundscapes are derived from items close to hand. We've got the strumming of the metal and elastic, as I mentioned in part 1, but I also used the recording of the Queen Mary's horn. Which I treated a lot in order to get a sense of the distant rumbling, thunderous type noises that I imagine emanate from such violent activity. The interesting thing was that when these tracks were mixed together, new sounds were born out of the mix on their own. They resulted from some weird sort of interference between the tracks themselves. And I was able to identify one particular sound, isolate that, and then use that throughout. It actually forms the angelic sort of cascading rain sound that you hear in part 1, and again I've picked that up in part 2. The soundscape captures these regular throbbing beats as the pressure builds prior to each violent eruption, which spews these vast water geysers from the subglacial ocean. Enjoy the piece. So we leave the violent sounds of the geysers behind as we move to part 3, Enceladus surface detail. Enceladus itself would sit in the North Sea. It's a small moon with a big story waiting to be told. Thick ice and massive crevasses, which are called the tiger stripes. And it's through the tiger stripes that the waters of the hidden ocean erupt. Enceladus could support life, and I believe that there are some probes being designed and that are destined to make an exploration there. So now we move into part 3 of the soundscape, where we have a lull in the activity of the geysers, and we reach a period of calm. The sounds here pick up from those in part 1 and 2. We've got the flicking of a piece of metal, which sounds like this, treated to sound like this. I've also picked up my flute after several decades and I've played a couple of very calm and quiet sort of background notes, which again I've treated to give a sense of calm, the calm that sits on the surface like a blanket in between the violent eruptions. Enjoy the piece. So there we leave the surface of Enceladus in total calm. And that concludes part 1, 2 and 3 of the Enceladus series. And now I thought it's an opportunity really to have a listen to the final piece, which is about the moon Io. Io is one of the 4 Galilean satellites or moons that orbits the gas giant Jupiter. Io is about the same size as the Earth's moon, and it's very close to the swirling, well, relatively close to the swirling cloud tops of Jupiter, which can be seen in various images from Voyager 1 swirling in the background. And a little bit like Saturn, the gravitational force of Jupiter warps Io. It places it under huge tensions, and this is likely behind the reason why there's such a high level of volcanic activity on this particular moon. The sounds here are a mixture. I've taken a sample from an archive from a NASA recording, but underneath that I've laid all kinds of sounds that I've recorded in the field. For example, we've got some wind turbines that sounded like this when recorded raw, and they sound like this after the treatment. We've got the sound of those distant, frenetic chainsaws, which sound like this in the field. And like this in the final piece. I also managed to get some really lovely radio tuning interference on a medium wave waveband, which I left untreated throughout most of the piece itself. And overlaid on that those tuning sounds, I also managed to get some pretty nasty medium wave, highly distorted, horrible radio on a car radio on a journey down the A38, which picked up one or two really, really difficult to hear tracks. You'll hear those in the main piece. And then just a couple more sounds. One of them is a ferry boat on the water with a fitting which was clanging against the side of the steel hull. So a very loud engine and a quiet clanging, which is quite indistinct. I was then able to treat that and reduce the sound of the engine noise and amplify the sound of the clanging. So that sounds like this. So that actually creates quite a calm, sort of melodic, hypnotic sound as you drift off as you cut through the ocean. Last but not least, a fire, just a fire crackling. And again, this was left pretty untreated. It just adds a little bit of crackly radio interference to the beginning of the track. So there we have it, really. Lots of different field sounds all mixed together to give us a sense of what it may sound like as we approach Io. And in due course, part 2 and part 3 will continue the journey to a close inspection of one of the volcanoes. And again, we'll carry that journey on to the surface of Io itself. So in this piece, which is Io with Jupiter Part 1, we hear how Jupiter's overwhelming mass, with its tempestuous vortices of gas clouds and violent storms, create a chaotic whirlwind of radio interference as we calmly approach Io itself. Enjoy the piece.
Yeah. This is a flight transport guidance. You want to talk to me? Hey, guidance FAO. Go. How about talking to my flight planner here a minute, will you? Follow the now. Yeah, go ahead. I'm on go, Dad. Very rough right now. I need to change my med out.
The ugly 85058 the text number.
The Doppler says that we did the right thing. That's right. So, do you need me? Yes, I sure do. We're still trying to figure out about that reference switch on channel 20 when we try to find out when we're going behind the moon. It won't tell us. I can tell you when you're going behind the moon. Can you tell us when the sun goes down? When the sun goes down behind the moon? Yeah, darkness and daylight's what we need. I can write that time. That's what I'm trying to figure out. What are you going to have time for me when we're behind the moon. I'll get that. Go select. Okay, what do you want this vector for now, Bill? Hold on for a second, would you? Alright. Dynamic pattern. So when can I run some sunrise sunset times and CSM relative to the moon? When the sun will be on the... When the moon will be in darkness, etc. When the spaceship will be in darkness, that's what I mean. And then sunlight, when it goes down the moon. You want to run sunrise sunset or moonrise sunset? I can run either one of those, can I? Right. Alright, okay, no problem. I can run them now. I can run them relative to the moon now, right? Okay. Alright, nothing. Everybody else, right? No. Yeah, you want sunrise and sunset, right? Right. Okay, I'll do it for you now. Okay. Stand up, right? No. Let me see the CSM descent, please. Start them in about 75 hours. Hold on a sec. Okay, that's good. I'll see you up there. That's good. Notice it's good. Is that Aaron, guys? Sorry, yeah. Did you get clearance on that thing for me? I don't have any. What do you think, girl? Why don't you run it anyway then? Okay, do you have any double line? Okay, this is for the mandatory double line. Work it out. No, just give me an attitude. Hang on, John. Dynamic better. No, okay. Two sunrise, sunset. Start them at 70. Start them at 77 hours.
On the line. Now we can talk about him all the time.
Oh, yeah!
I'll start it at 77 hours. Say again, I got it. That's sunrise. That's when it goes to sunrise, huh?
I understand that. Well, we're still discussing the next move.
Flight plan for Dynamic. Go ahead, Dynamic. Is Arrow 13 or is Arrow 0 looking down the Z-axis? Stand by just a second. Neil?
We're looking real close at water usage profiles, and right now things are kind of pointing toward leaving the IMU powered up, far down the LGC, but we'll have more work for you shortly. We recommend for sleeping that you leave one guy and watch. We recommend you don't make any urine dumps.
Dynamic flight plan support. So, are you talking about the instrument we have assigned for the LIM? Talking about LIM instrument L13, right. Go ahead. Does 00 put you down the Z-axis?
You might want to transfer.
I don't even have it. I don't even have that in my list. FAO better. Is that enough for you? Stand by. I do need more.
Right up that we can help you out with at the moment.
One thing to consider, Grant. That's when you go to
That is an update on the confinement anyway now.
Oh, we're in good shape there. We're in sunset, sorry. Let me get earlier now. Dynamic battle. Start the sunrise, sunset at 75 hours, please. That's almost sunset time. 40 is
So that's the end of Io with Jupiter Part 1. I just remembered listening through to that the chirpy, crickety sound right at the very end, well, that actually came from a really large green grasshopper that we found in our house. It was an amazing insect, and I was lucky enough to be able to record that and include that within the piece. So that concludes the moons of the solar system so far, with Enceladus Part 1, 2 and 3 and Io Part 1. It's work in progress. I've hopefully got some ideas for Io Part 2 and 3, and I've also some plans for Europa, which is another icy moon that orbits Jupiter. If you'd like to find out more, just search I Am the How, all one word, and thanks for listening.
Okay, what do you want this vector for now, Bill? Hold on for a second, would you? Alright. Dynamic pattern. When can I run some sunrise, sunset times and CSM relative to the moon? When the sun will be on the... When the moon will be in darkness, etc. When the spaceship will be in darkness, that's what I mean. And then sunlight, when it goes down the moon.